One of the most common laboratory experiments when studying acid-base chemistry is the performance or the completion of a titration of an unknown acid or unknown base with its counterpart. Okay? So in this video I just want to show you a simple schematic of a titration, the purpose, how you set it up, how you perform a titration, since so many in chemistry classes often perform an experiment of a titration. Okay, so a titration, the purpose of it is to determine the molarity, the concentration of an unknown solution. Okay, in this scheme here, what we have is we have a Erlenmeyer flask, and in that Erlenmeyer flask we have an unknown substance. Okay, now we do know that this unknown substance is an acid. Okay, and so we have an unknown acid. We don't know its molarity, and that's what we're trying to determine. Okay, so to do that, we, in a graduated burette, okay, we put a base solution, okay, a basic solution that has the OH, has the hydroxide ions, and that solution, we do know the concentration, and because it is a graduated burette, we will be able to determine the amount or volume of OH solution that is added to the unknown acid. And we slowly drip or fill the flask with the OH solution, with the base solution. But how do we know when that solution has been neutralized? How do we know when all of the OHs we have added have been neutralized with the H plus ions in the acid? Because just by looking at the solution, we won't see that neutralization. Okay, there has to be a way for us to visually see it or to measure it using some sort of sensor or probe. One of the most common substances to use for that visual indication is what we call an indicator. Okay, we put an indicator into the solution. Now, an indicator in this picture here, you can see it turns bright pink when it hits the equivalence point, so the neutralization is complete. We use one called phenolphthalein. I'll write it here for you. It's one of the most common indicators that is used. Phenolphthalein is a compound that in the presence of bases, it turns a pink, light to really bright pink color. But in the presence of an acidic solution, it stays colorless. So it shows us just simply whether or not the solution is basic or if it's acidic. So as we drip in the basic solution and it is neutralized with the unknown acid here, the solution that we're making here, the pH is changing from a pH and getting up and up and up, closer to 7, to the neutral pH, and then eventually will hit a basic pH. Okay, a basic pH. And as soon as the solution here that is in the flask is in the basic pH range, the indicator, the phenolphthalein, will turn bright pink, giving us a visual indication that the neutralization is complete, that we should stop adding base, that all of the acid is neutralized. Now, what we obtain from this experiment is we will know the volume of unknown acid used. Okay, we know that because we will predetermine how much acid we put into this flask. We will know the volume of base used because we start with a certain amount of base in our graduated burette, we drip it in, And when we finish, we can easily measure and read the difference in the volume of the burette before and at the end of the titration. So we will be able to see the volume of the base used. Also, we know the molarity of base used here. Okay, we know the molarity, the concentration of base, because we predefined what base, how much base, and the concentration being used that, here in this burette. So we know the molarity of the base, we know the volume of the base used, we know the volume of the unknown. So then we can run some stoichiometry calculations and conversions to determine that molarity, that concentration of the unknown acid. That's what we can ultimately figure out, because that we do not know at the beginning of this experiment. Okay, so, and we know that molarity is equal to moles per liter of solution. See, and that's where we can take this volume of base, put it right there. We can put the molarity of base used right here, and then we will be able to solve for the moles of base, which will tell us the moles of hydroxide ion that were neutralized, and we know that hydroxides react with H pluses, those protons from the acid, into 1-to-1 ratio, you see. And we'll be able to figure out the molarity of the unknown acid.